For today, let's talk about the maximum and minimum of a function given a graph. There are four terms here I want you to remember and to know. And the first one is the absolute maximum. This is the point with the largest y value across the domain. So if you look at this graph, we can clearly see that this point has the highest y value, and that's negative 2 comma 6. That's the those are the coordinates of that. And then we have also the absolute minimum, and that's the point with the smallest y value across the domain. So in this case, we have, or that point is at 0 and negative 4. Now we also have what we call relative maximum. So here, this is the point with the largest y value in a region of domain. So you will just compare this to the other points given a certain part of the graph. In this case, let's say this is the portion of the graph we're talking about, then that means that the relative maximum is at negative 6 and 4. And of course, we also have the relative minimum, and similarly, the definition is the point with this time the smallest y value in the given region. So I think you already know the answer here. So let's say we're talking about, again, I'll encircle that, this region, then that means that the relative minimum is at negative 4 and negative 2. Okay, so for the first, I'm going to give you 3 more examples. For the next one, I'll give you 10 seconds to identify the following, okay? The relative, absolute, relative, and absolute maximum and minimum. Timer starts now. All right, so that's it. Relative minimum, if your answer is at negative 8 and negative 4, your answer is correct. Absolute minimum, I think that's obvious here. It is at 0.0 and negative 6. Relative maximum, okay, what is that? Okay, that's negative 4 and 6. Okay, now for the absolute maximum, okay, so in this case, it does not exist. I think I need to mention this. In some cases, you will not all these 4 terms. Some cases, you will miss 1, sometimes 2. Now, maybe you're thinking, well, there is another y value that is higher than the relative maximum, right? That's 6. But we will never be able to know that because of the arrows. So those 2 arrows means that part of the graph extends indefinitely upward. So we will never be able to identify the highest y value. That's why the absolute maximum does not exist. Okay? All right, let's have another example. 10 seconds again. Timer starts now. All right, so relative minimum, if your answer is at 3 and negative 3, your answer is correct. Let's have another. What about the absolute minimum? Okay, so again, does not exist because that arrow means it extends indefinitely downward. We will never be able to identify the smallest y value. Relative maximum is at 1 and 5. And similarly, just like absolute minimum, we don't have absolute maximum. It does not exist. Again, that arrow extends indefinitely upward. We will never be able to identify the exact highest y value. Okay, let's go to the last example. Again, 10 seconds for this. All right, relative minimum. What is that? That is at 1 and negative 1. Absolute minimum, all right, does not exist. Very good, because of the 2 arrows. Again, those 2 arrows will they extend indefinitely downward, so we will never be able to identify the lowest y value. Relative maximum does not exist. And maybe you're thinking, why is that? Well, because these 2 are equal. and incidentally, they are the highest. So that means we have two absolute maximum points, and they are -1 and 4, and 3 and 4. So yes, there is a possibility that there will be more than one absolute maximum or absolute minimum. All right.